Opamp types. Characteristics of different Opamp types. One. N-channel diff pair. The threshold voltage is the voltage level at which the N-channel MOSFET begins to conduct current between its source and drain terminals. For an N-channel MOSFET, the threshold voltage is typically positive. This means that the input voltage applied to the gate terminal must be greater than the threshold voltage to ensure proper device operation. The lower limit of the input range is defined by the threshold voltage. The input voltage must be higher than the threshold voltage for the MOSFET to properly turn on and conduct current. For N-channel diff pair, the input upper limit is usually its supply VCC. Two. P-channel diff pair. The threshold voltage is the voltage level at which the P-channel MOSFET begins to conduct current between its source and drain terminals. For P-channel MOSFET, the threshold voltage is typically negative. This means that the input voltage applied to the gate terminal must be lower than the threshold voltage, in absolute value, to ensure proper device operation. The lower limit of the input range is defined by the threshold voltage. The input voltage must be lower, in absolute value, than the threshold voltage for the MOSFET to properly turn on and conduct current. For the P-channel diff pair, the upper limit is usually ground. The output range cannot exceed the supply voltage because the MOSFETs operate within the limits imposed by the supply voltage. The biasing conditions of the differential pair, such as the bias current and the DC bias voltages, play a crucial role in determining the output range. The biasing ensures that the differential pair operates in the desired region of operation, such as the linear region or the saturation region. It's important to note that the output range of the differential pair is generally limited by the supply voltage and the voltage headroom required for proper operation. Output swing is limited by the transistor VDs. N-channel and P-channel diff pair with an output inverter is suitable for comparators that swing rail to rail. Some N-channel and P-channel diff pair use some push-pull output stage for enhanced driving current capability. Three. Enhanced N-channel diff pair with zero threshold voltage device at the input stage. This type of N-channel diff pair type is suitable for much higher input range signal. 4. Operational transconductance amplifier. This type of Opamp consists of an N-channel diff pair at the input stage and a current buffer at the output stage. This type of Opamp is suitable for applications that require a high input range and stronger driving capability. (5) OTA with rail-to-rail range at input and output. This type of Opamp has an N-channel and P-channel in parallel at the input stage and a current driver at the output stage. All this leads to rail-to-rail, high gain, and high bandwidth Opamp. (6) N-channel and P-channel in parallel at input with fully folded cascode output stage. This type of Opamp has rail-to-rail input and rail-to-rail output with high supply noise rejection capability. It also has a high common mode rejection ratio. This Opamp is suitable for power supply provided by pumps with limited power consumption. It has high gain and high bandwidth characteristics.